The stream function equation is a matrix equation, but the vorticity equation is a system of first-order differential equations. We're going to use the power of MATLAB and their ODE solvers to solve this equation. So in order to use the ODE solver, we need to compute the right-hand sides of the differential equations. The right-hand side depends on the stream function, so we're going to need to solve for the stream function at every time step. We know how to do that using a matrix computation. And we're also going to need the boundary conditions on the vorticity, because these right-hand sides then have an I+1 index and a j+1 index, an I-1 index and a j-1 index. So how many ODEs do we have here? These are just, this equation is only valid for the interior points of the domain. So we have n-2 times m-2 ODEs to solve. Okay? But we need to use the boundary conditions. So let's review the boundary conditions. So we've assuming that we've already solved the psi equation. So we have psi on the entire domain, including the boundaries. But we're only going to be computing omega for the interior points. So we need omega on the boundaries. So we have the boundary condition for omega on the cylinder. So that's the first point in I and j. We've computed what this is. This is given in terms of the stream function, psi at the third point away from the cylinder, minus 8 times psi at the second point. This is the 2 points away from the cylinder, but it's the third grid point. And psi at 1 point away from the cylinder, but it's the second grid point, divided by 2h squared. So that's the cylinder boundary condition. We have the free stream boundary condition, omega n comma j equals 0. And then we have the boundary condition in the polar angle. So we have omega I comma 1. The first grid point is then equal to omega I and the m-1 grid point. That's the periodic boundary condition. And finally, we have omega I and the mth grid point is equal to omega I and the second grid point. So these two are the periodic boundary conditions in theta. So we put in these boundary conditions for omega so that we can compute the right-hand side for all of the interior points when ij represents an interior point. Okay, what ODE solver should we use? I tested the ODE 45 and I tested the ODE 23. This one turned out to be faster, more efficient. So I would recommend everybody use ODE 23.m as the ODE solver. Okay, so let me review. So most of the computational time will be spent calling ODE 23 in order to integrate the vorticity equation. To integrate the vorticity equation, you have to compute the stream function. So you have to solve the matrix equation for the stream function. And then you need to compute this right-hand side for all the interior points on the grid. ODE 23.m will do the hard work of doing the integration in time. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.